Have you ever hit a problem that's just so complex with so many different options that finding the absolute best solution feels, well, impossible? What if I told you there's a new type of computer coming, one that doesn't just think in ones and zeros, but in the really strange, really cool language of the universe itself? Today, we're diving into the mind-bending world of quantum computing, a technology that's gearing up to solve the unsolvable.
So, here's what we've got lined up. We're going to start with the weird rules of the quantum world, then see how those rules power these new kinds of machines. After that, we'll look at how this could literally optimize our future, change communications forever, and finally, we'll get real about the huge challenges that are still in the way.
All right, first things first, the quantum world. To even begin to get this revolution, you have to start with the main building block, a tiny particle that takes the good old computer bit and gives it some serious superpowers.
Okay, so the device you're watching this on right now runs on bits. And a bit is basically just a light switch. It's either on, a 1, or it's off, a 0. That's it. A quantum bit, or qubit, is a whole different ballgame. Don't think of it as a switch, think of it as a spinning coin. While it's spinning in the air, it isn't heads or tails, it's kind of both at the same time. And that ability to hold multiple values at once, that's the quantum leap.
And this whole spinning coin idea, it has a name. Superposition. It's the secret sauce that lets a qubit check out a massive number of possibilities all at once. But, and this is a huge but, the second you try to look at it, to measure it, poof, the superposition is gone, the coin lands, and it collapses into just one state, either heads or tails, a 1 or a 0. All the magic happens before you look.
This sphere shows you that power perfectly. A normal bit can only be at the very top or the very bottom. 2 spots. That's it. A qubit, though, can be any point on the entire surface of that sphere. You can just imagine how much more information that holds. That's where all this incredible computing power comes from.
Okay, so we've got these super powerful qubits. Now what? How do we actually take that weird quantum behavior and get it to, compute something? How do you build a computer out of spinning coins?
Well, it really boils down to 3 main steps. First, you get the qubits ready, basically putting them all into that spinning superposition state. Second, you run your program, which is a series of what are called quantum gates. These gates poke and prod the qubits, making them interact in very specific ways. And third, you measure the result. All the qubits collapse, the coins all land, and that final pattern of heads and tails gives you the answer.
And this is what that program actually looks like. A quantum circuit is like sheet music for a quantum orchestra. Each line is a single qubit, and every little symbol on it is a quantum gate, an instruction, a single note telling that qubit exactly what to do. It's the precise manual for this really complex dance.
Of course, you can't just run your everyday software on these machines. You need specialized quantum algorithms. These are like special translators that can take a really hard real-world problem and rewrite it in a language that the quantum computer can actually understand and tear through. So this is all fascinating, mind-bending stuff, but why should you care? What can we actually do with all this? Let's take a look at how this tech could tackle some of the biggest challenges we face.
At its heart, what quantum computing is absolutely amazing at is optimization. This quote is about finding the best way to split up a network to get the most connections. It sounds a little abstract, I know, but so many of our biggest problems, from shipping logistics to designing new medicines, are really just incredibly complex versions of this. It's all about finding that one best answer out of a bazillion possibilities.
The perfect example is the classic traveling salesman problem. The goal seems simple, right? Find the absolute shortest route to visit a bunch of cities. If you have like 4 cities, you can figure it out. But once you add more, the number of possible routes just explodes. It gets so big, so fast, that even our best supercomputers would take centuries to check them all. A quantum computer doesn't check them one by one. It finds a whole new way to find the best path.
And look, this isn't just about finding the best road trip. Think bigger. Imagine using this to design a new life-saving drug in a fraction of the time, or creating financial models that could help prevent the next market crash, or optimizing global supply chains to cut waste and emissions. Solving this one type of problem could unlock massive progress in just about every field you can think of. Okay, let's switch gears. We're going to look at another massive revolution this could spark: the future of how we all connect and communicate with each other. Because quantum isn't just about building faster computers, it's about building a whole new kind of network. Just think about our future networks, like 6G. The demands are going to be insane. Everything connected to everything else, all in real time. Trying to optimize a network that massive is a perfect job for a quantum computer. But there's also a pretty serious threat that comes with it.
Yeah, here's the dark side. That same incredible power that makes quantum computers amazing at solving optimization problems also makes them a huge threat. A powerful enough quantum computer could, theoretically, smash through the encryption that protects almost everything in our digital lives. Your bank account, your private messages, everything.
Luckily, quantum mechanics also gives us the solution. See, our security today is based on math problems that are just really hard for normal computers to solve. The quantum version, called quantum key distribution, is based on the actual laws of physics. If anyone tries to eavesdrop on the signal, the very act of looking at it changes it, and you know instantly you've been hacked. It's basically unbreakable security.
And this idea leads to something even bigger, a quantum internet. Now, this wouldn't replace the internet we have today, but it would work alongside it. Instead of sending regular bits, it would send qubits, which would allow for that ultra-secure communication. And it would also let us link quantum computers together around the world to make them even more powerful.
So, how does information even travel on this new network? Get this, they call it a flying qubit. The quantum information isn't sent as an electrical signal down a wire. It's actually encoded onto a single particle of light, a photon, and beamed to its destination. This is stuff that used to be pure science fiction.
Okay, let's take a breath and come back down to Earth for a minute. This incredible future isn't here tomorrow. Building these machines is honestly one of the greatest scientific and engineering challenges of our lifetime.
Right now, we're in what experts call the NISQ era. That stands for Noisy Intermediate Scale Quantum. Noisy means our qubits are super fragile and mess up if you so much as look at them wrong. Intermediate scale means we just can't build them with enough qubits yet to solve most of these huge problems. So yeah, we are still in the very early days.
But make no mistake, progress is moving faster every single day. The potential here to completely change medicine, finance, AI, it's undeniable. So the question really isn't if quantum computing is going to change our world, but how fast. Which leaves us with the biggest question of all, are we going to be ready for it when it does?